Naka-present na. Makita na ninyo ang shared screen. Wala pa. Wala pa naka-share. Ayan. Ayan, share na. So let's just have a review on what we had yesterday. So yesterday we discussed this, na? Your infinite series. Mabilisan lang to ha. Review lang natin what we had. So we discussed sequences and convergence of a sequence. And then what have we learned? Your variable, your infinite series is a powerful tool that you can make use of to express your functions as infinite polynomials. And we wanted to learn yesterday about the formula for the general term of a sequence, and then to be able to calculate the limit of a sequence if it exists, and then determine the convergence or divergence of your sequence. So we learned about your infinite sequence to be an ordered list of numbers, and it is of this form: a sub 1, a sub 2, a sub 3 up to a sub n. So we call this a sub 1 is one term and down the line. So we have also learned that we can actually make use of this notation to denote this sequence. Just remember that although it looks like a set notation, it's not the same as your elements of the set, because for a sequence, it is supposed to be an ordered list, whereas a set is not ordered. And because a particular number a sub n exists for its positive integer n, then we can actually define a sequence as a function whose domain is the set of positive integers. So, for example, this is an ordered list. No, you know that the next number after this will be 64, and this is your first term, second term, third term, or we call it a sub 1, a sub 2, a sub 3, a sub 4, a sub 5. So from this pattern, you will be able to get your nth term. So your nth term will be the following. Since if you notice, if your a sub 1 is 2, a sub 2 is 2 to the second power, and a sub 3 is 2 to the third power. So it is of this form. Yan, a sub 1, 2 to the 1, a sub 2, 2 to the second power. So we can have an explicit formula for the nth term. And what is that? It is a sub n, which is equal to 2 to the n. We also learned about the different way, so a different way of describing the sequence, which is your recursive formula. No? You can make use of your recursive formula, making use of the previous term a sub n minus 1. So you can rewrite your recurrence relation a sub n to be equal to twice of a sub n minus 1. This is what we had learned yesterday. So mabilisan na lang, no? Parang review lang. The difference between your geometric and arithmetic sequence is that for an arithmetic sequence, you add, now there is a value called the common difference, which you can either add or subtract, depende sa pattern to the next term. Okay, that's for an arithmetic sequence. So why you have a formula there given by the following formula. That is a sub n equals a sub 1 plus the quantity n minus 1d, where a sub n is the nth term, a sub 1 is the first term, and then you have d is the common difference. Yeah. n is the term number. That's why you have a sub n. So we completed this already. Remember that we completed that one last time. And then 12 pa lang, huh? So we consider the following sequence. This one, 2 minus 2 over 3, 2 over 9, up to this. So notice na alternately positive and negative, no? So we know that after 2 over 81, the next one would be a negative value. So also, there is a ratio that is being multiplied to get the next term. So when you multiply 2 by negative 1/3, you come up with negative 2/3. When you multiply negative 2/3 by negative 1/3, you come up with 2 over 9. So and down the line. If you multiply 2 over 81 by negative 1/3, then you will get the next term also there. So when you know that the pattern continues, this is actually a geometric sequence and it can be defined recursively as a sub 1 equals 2, a sub n equals negative 1/3 times a sub n minus 1. So that's what we did here earlier. So if you try to write down all the values in that manner, then you'll be able to find the explicit formula, which is a sub n equals twice of negative 1/3 raised to the n minus 1. This is already posted in your mole. So, pwede na lang yung i-review, na? Ayan. So, 2 to the n is a geometric sequence. So, I'll end up with this review here so that we can go to the next topic, which is our topic for today. Tingnan mo natin. Ito yung example na ginawa natin, no? We try to find the explicit formula for the nth term of the sequence. Itong mga to, dito. Ito siya, yung dalawa, yung diniscuss natin kahapon. So, to find the explicit formula, I gave you some details on how to do it. Okay? So, I guess that's enough for the review. And then, let's go to our topic for today. How many are you now? 20 na. So, pwede na muna tayo mag-take ng picture. Will you please open your camera for the attendance? Asan ba yung ano niya natin? I'll stop presenting muna so that I can see you. Okay. Hello, guys. Let me just... Yan natin. Change natin yung layout para makita ko kayo. At, ayan. Ayan. Hello, how are you? Sige. Print screen. Okay. And then, let us just post it in our... Everybody's a member of the group already. Today is October 6. Ay, October 6. One more. Ayan, na-post na. Ilan na ba kayo lahat na member ng group? Konti pa lang yata. This is our... We join your group, ha, for the announcements. I-post ko sa chat box natin ngayon para makita ninyo. So, you try to join our group. Okay, nandito na sa chat box. Hello, Michelle. Good afternoon. Sino pa ito na? Si Robert Tagores. Good afternoon. Ayan. Ay, bakit prepare pen and paper and calculator? Hindi ko pala na-post yun kanina. Cut. Ando ko na lang yan. Please prepare your pen, paper, and calculator. Nakadugtong doon sa ano. Hindi ko pala na-send kanina. So, ito yung... Ay, yun pa rin. Ayan na lang. Okay. Ayan. Ito yung group, ha? Maklik ninyo. Yeah. So we're going to start with our topic for today. Ayan. For today, we're going to discuss Lecture 9B. Lecture 9B. Lecture 9B. Lecture 9B is a continuation of the topic on infinite series, but this time we will be talking about the monotonic and bounded sequences. So let me just share. Naka-share. Wala pa ito naka-share, no? Share muna natin para makita ninyo. Ayan. Entire screen. And this one, share. Okay. 9B. Ito. So, this is on 9B. Makita nyo na ang shared screen, guys.
Yes, ma'am.
Okay. So, we're going to talk about, this time, the monotonic and bounded sequences. Later on, siguro next week na to, no? Infinite series of constant terms and your test for convergence or divergence. But you can study ahead if you have the time, okay? So, for sequences and convergence of a sequence, natapos na natin yan yesterday. As I've said, you can actually take a look at the PDF na sinend ko na, naka-post na sa Mole. Okay? This one, we talk about this, about the use of your infinite series. Also talk about the intended learning outcome yesterday. So this time, we again have the following definition about increasing and decreasing sequences. So when you say a sequence A sub n is increasing, this will be true if A sub n is less than or equal to A sub n plus 1 for all n. Meaning to say, increasing siya if the next term is greater than the prior term. Okay? And it is decreasing if, okay, the prior term is greater than or equal to the next term for all n. So, yun ang ibig sabihin ng increasing. Ang increasing, yung prior term, yung previous term, mas maliit kaysa sa next term. Whereas decreasing, pag mas malaki yung prior term compared to the next term. Diba? Kasi ordered man yung list. Now, if a sequence is increasing or decreasing, then we call it monotonic. Otherwise, if it's not increasing nor decreasing, then it is not monotonic. So, yun ang ibig sabihin ng monotonic sequence. Now, we're going to solve for the following. Determine whether it is increasing, decreasing, or not monotonic. So, let's take a look at letter A. If you take a look at letter A, what would be the first term? When n equal to 1, what would you have?
1/3, ma'am.
Yes, 1 over 2 times 1 plus 1, so 1/3. What's the next term when n is equal to 2?
2/5, ma'am.
2 over 5, yes. So, I ask you to have your calculator with you. So, if the first term there is, that 1/3, then what is 1/3? 1 divided by 3, is it 0.3? Correct ba itong binigay ng mga estudyante ko kaninang umaga? 0.3 man daw. Correct? 1 over
Yes, ma'am.
Okay. 2 over 5 is 0.4. Is that correct? Sige daw. Binigay kasi nila itong mga values
Yes,
kanina.
ma'am.
So, hindi ko natin.
Sakto, ma'am.
Okay. 3 over 7 is 0.42. check na, tayo na lang mag-verify. Is
Zero
that
point
correct?
42 ma'am.
0.43, ma'am.
So, mag 0.43 siya.
43. Sige. 0.43. Sana sahip sila gamay. Kaning 4 over 9. Ato nang i-correct.
Sakto,
Ay,
ma'am.
sandali. Balik ko. Wait, kaya ato nang i-ikuan. 0.43. Matagal kasi magsulat kaya ano. Ayan. So, what did you notice? Is it increasing or decreasing?
Increasing siya, ma'am.
It's
Increasing,
increasing.
ma'am.
Okay, so you already have an idea that your, di ba, ang nth term would be n over 2n plus 1, and the n plus 1 term would be n plus 1 over 2n plus 3. So you're going, remember that you are asked to determine if it is increasing. Based on the values that you have, 0.3, 0.4, increasing siya. But you have to prove na increasing siya all throughout. Okay? So you make use of these terms here, the nth and n plus 1 term, and come up with the following. Okay? So you have this n over 2n plus 1 is now less than or equal to, ano yun, di ba? Ang sunod kay n plus 1, increasing man siya, so kani mas gamay sa katong next na term. Okay? So, you just base this on the values that you got earlier. Pero you have to show. So, notice that when you have to show this, you can actually make use of the fact that you can multiply the LCD, or you can simply cross multiply. So, you come up with n times 2n plus 3. Then, kani siya plus multiply dito, then you would have n plus 1 over at times 2n plus 1. Okay? So, what is this? This is 2n squared plus 3n. And this is, you make use of your either long multiplication, or pwede kaning n times 2n is 2n squared. 1 plus 2n is 2n. 1 times n is n. So, you have 3n. And you have 1 times 1. Okay? So, binomial man kasi yan, at saka binomial. So, meaning to say, you come up with a value which is this. You multiply, inulit lang yun doon para hindi tayo mawala. Yan. That becomes 2n squared, okay, kanina, plus 3n is less than or equal to, when you multiply these two, you come up with 2n squared plus 3n plus 1. Which is true. Why? This is 2n squared plus 3n less than or equal to 2n squared plus 3n plus 1. Kasi ito may plus 1 siya. Okay? So, that means to say that the inequality holds. Because the right-hand member, or the right-hand side has a plus 1. Ito lang man siya. Ito, hanggang dito lang. This one is that one. Pero this one is should be greater kay na aside from 3n, na pa siya additional na 1. So, the sequence is actually indeed increasing. Kay na-show man ninyo na true ni siya. So, because you suspect in general that ani ang case. Diba? Katong pag-solve na 0.3, point, ano yun, 0.3, 0.43, and then after that is yung next number na po. So, from there, based on your suspect na ano siya, na increasing siya, you have to show that it is indeed increasing. So, when you claim it, you should have a proof that it is increasing. And from here, you can see that indeed it is increasing, increasing. Yeah. Okay? About the next one, yung next problem. The next problem says that you are asked to determine whether this is increasing or decreasing. What's the first term? When n equal to 1, what will you have?
1, ma'am.
1. When n equal to 2, you will have 1/2, correct? Then 1/3, then 1/4. Okay? So, ito siya. 1, 1/2, 1/3, 1/4. Again, kinumpute na din ng mga estudyante kanina sa MAT071 this morning. So, 1/2 is 0.5, 1/3 is 0.3, 1/4 is 0.25. What did you notice? Is it increasing or decreasing?
Decreasing, ma'am.
Decreasing, yes. So, again, suspect pa lang yan ha, na decreasing siya. Pero, you make use of this. Notice that ang divisor, okay, sa next term is bigger than the divisor here. So, meaning to say, mas gamay gid actually kaning next, no? Ma-decrease gid kay nga no, mas dako ba yang ihang divisor. Okay, so inyohang numerator kay 1 man or this one, your dividend is 1 man, pareho lang na 1 ang dividend. So, mas magamay gid ni 1 over n plus 1 is less than 1 over n. So, that's a fact already. Okay? That you will have this one, kaya gamay man ni, this one is less than, okay, less than siya, ana. 1 over n plus 1 is less than 1 over n. Or 1 over n is greater than 1 over n plus 1. You can read this as 1 over n plus 1 is less than 1 over n, or you can read it as 1 over n is greater than, kani mas dako ni kaysa sa next na sequence for all n. And that means to say, kay mas dako man ang prior, sa next, the sequence is decreasing. Okay? You don't have to, klaro naman ni, kana naman ni, mas gamay man ang value ani kay mas dako ang iyahang divisor. For the other one, the other problem, ito. Yan. What's the first term of this one? That's the first term. When n is equal to 1. Okay, when n equal to 1, you will have squared yan dito. Tapos 1 sa baba. So you have 1. When n is equal to 2, we'll have negative 1/2. Correct? Pag 2 siya, may mo naman siyang, okay, 2 yan sa ubos, then 2 plus 1, that's 3. So that's why negative. When n is equal to 3, you will have, may mo ng 4, ang inyong exponent. So positive na po ang 1. Okay, then 3 ang sa ubos. Okay, so klaro ni. Now, remember that you are asked to determine if it is increasing, decreasing, or not monotonic. So in this case, what do you think? Is it increasing? Is it decreasing? Or not monotonic? Yes, sir. Tanawa, based on the nth and the n plus 1 term. Nga, may idea? Makita ninyo? Diba? If we take a look, alternately positive and negative siya. So, dili kani 1 is greater than negative 1/2. But negative 1/2 is less than 1/3. Then 1/3 na po is greater than negative 1/2. I'm sorry, the negative 1/4. And down the line, so, kani siya, depende kung unsang n value ni mo diha. Okay? So, in general, what we have? For 3 consecutive elements, a sub n, negative 1 to the n plus 1 over n, and a sub n plus 1, negative 1 to the n plus 2 all over n plus 1, and that one, if n is odd, you will have a sub n is greater than a sub n plus 1. And a sub n plus 1 is less than a sub n plus 2 if n is even. So what does it mean? The sequence is neither increasing nor decreasing. So what's the conclusion? It is not monotonic. Because for it to be monotonic, dapat either increasing or decreasing. Yan karon kay dili man madako siya, then magamay na po, then madako na magamay na po. Okay? So, we now talk about your monotonic and bounded sequences this time. Pero before mag-talk ka sa inyong bounded sequences, let us have a definition of what is a lower bound. A number L is called the lower bound of the sequence if, this is the pointer para mas klaro, if L is less than or equal to A sub n for all positive integer n. Ano ibig sabihin yan? Lower bound daw siya, ang L. Kung ang L kay mas gamay siya, less than or equal to any element of the sequence, less than or equal to any element of the sequence, kaya mo siya for all positive integer n. So, mas gamay siya, ikaw nga kay lower bound. Okay? But, a number u is called an upper bound, okay, of the sequence if a sub n is less than or equal to u for all positive integers n. That is, if ma-upper bound siya, pag kaning u there, is an upper bound, mas dako siya sa any element of the sequence. Greater than or equal to, pwede po siya ma-equal. Exactly equal siya. Upper bound na siya. So, kung ang sequence mo, example, increasing siya, then, ang imong upper bound kay naa diri sa imuhang diri dapit, sa right. Pero kung decreasing siya, decreasing pa durong diha, ang imong upper values kay naa diri sa left, di ba? Okay. So, you have to be very careful to analyze the problem kung asa dapat ang inyong upper bound o asa po ang inyong lower bound. Okay. If alpha is a lower bound of a sequence, and if alpha has the property that every lower bound L is less than or equal to alpha, then we have what we call your greatest lower bound. So, kunyari, naatanan diri inyong lower bounds, naatanan diri. Then, naa kay pinakadako sa tanan nga mga lower bounds. Ang tawag kato sa pinakadako sa mga lower bound kay greatest lower bound. Okay? Sometimes your greatest lower bound is also named as infimum. 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 Ano siya? Wala nakasulat dito. Ayan. Infimum. Ang greatest lower bound is the infimum of a sub n element of n. On the other hand, beta is an upper bound of a sequence if beta has the property that for every bound u, beta is less than or equal to u. So, upper bound siya kung tanan niya mga, dili yung mga sequences a sub n. Yan nakadiri dapita sa taas, dapit. So, you are an upper bound. But that upper bound, kani si upper bound, kay naatay gitawag nga least upper bound. Ang least upper bound is katong pinakagamay sa mga upper bound. And ang tawag ana sa least upper bound is your supremum. Supremum sa a sub n. Okay? So, least siya, pero nga nung supremum man siya, basta, mo na yung term. No? Least upper bound na siya sa greater values sa inyuhang a sub n, pero pinaka-least is called the supremum. Para hindi kayo maano, di ba, ang iyang notation nga ni kay LUB, least upper bound. Ang greatest lower bound kay GLB. So, ang lisod mo ang mag-recall aning soup. So, pag soup gani, LUB na siya na U. Na U. So, ang isa, muna siya ang infimum. Ang sa infimum, kay muna ang sa GLB or the greatest lower bound. Okay. So, let's go here. If a sequence is, I have actually here, this is a remark. If a sequence is increasing, then the first element of the sequence is the greatest lower bound of the sequence. What does it mean? Kaya ng sequence nimo kay ni increase pasaka, no? So, ang first element kay increasing man siya. So kani mo na diri ang mga gagmay pasaka diri. Then the first element of the sequence is the greatest lower bound of the sequence. Kay since increasing siya, tanan na diri sa ubos, mo na inyohang mga lower bounds. Ang first element niya mo ay pinaka dako na lower bound. So that's the greatest lower bound. Class, are you still with me?
Yes, ma'am.
Nasundan pa? Sige.
Yes, ma'am.
Medyo
Yes,
mahirap
ma'am.
ito na medyo mahirap na concept itong GLB at saka LUB at saka SUP, no? SUP, supremum is your least upper bound. And then infimum is your greatest lower bound. Okay? So if a sequence is decreasing, so itsura man pag decreasing. Pag decreasing, naadili ang dako, dila, paduhong diha ang gamay. No? Decreasing. Okay? So if a sequence is decreasing, then the first element of the sequence is the least upper bound. So kay kani man diri decreasing man siya, so mga na diri mga dagko paana paubos. So least upper bound, no? Na type. Least upper bound ay katong first element. Kay na diri mga upper bound sa mga dagko. Correct? Example siguro para makita ninyo. So here, illustration. Kani, n over 2n plus 1. Ang first element sa n would be, when n equal to 1, you will have 1, 2 times 1, that's 2 plus 1. 2 times 1, sorry, that's 2 plus 1, that's so you have 3. So 1 over 3. Ang second element is will be 2, 2 times 2, that's 4 plus 1, so you have 2 over 5. Third element, or third term, is 3, 2 times 3, that is 6 plus 1, so you have 7. And then, sunod na po na. Okay. Now, if you take a look at this, ang elements niya kay 1/3, 2/5, 3 over 7, 4 over 9. It says that it has a 0 as a lower bound. So, ang 0, kay, di ba, naman diri ang, is this increasing, decreasing, by the way?
Decreasing, ma'am.
1/3. What is 1/3? Sige daw, i-compute daw sa para makita na to. Increasing mode siya. What is 1/3?
Increasing there, ma'am.
So what is 1/3 muna? Give me the value for 1/3. 1 divided by 3. Sige.
0.33, ma'am.
Okay, 0.3. 0.3. Kanina lang, kamihirapan ako magsulat. 2/5. What is 2/5?
0.4, ma'am.
0.4. What is 3 over 7?
0.43, ma'am.
0.43. Sulat. 0.43. At least may 3 na ta na elements sa sequence. So, if you take a look, it is increasing. So, ang pinakadako karon would be, at this point, ang pinakadako kay 0.3. I'm sorry. Ang pinakadako kay 0.43 at this point, no? Kay 3.4, 0.43. So, before that, okay, kaning mga numbers nga naa diri, mga lower bounds na sila. Kay mas gagmay man ni sila diri, di ba? Pasaka man, correct? So, kaning among these lower bounds, ang inyong 1/3 kay mo na ang greatest na lower bound. Diba? May pinakadako na lower bound. Pero ang 0 is also a lower bound. Correct? Kaning mga number after 0, lower bound gihapon sila. Pero ang greatest lower bound is 0.3. Muna gitawag GLB ang 1/3. Okay? Ang sa gani ng GLB, muna ang infimum. So, ang infimum kay of the sequence is 1/3. In fact, any number less than or equal to 1/3 is actually a lower bound. Pero ang GLB, kani ang greatest lower bound kay 1/3. Nasundan? Nasa ganing GLD? Infimum, ha? Of the sequence. So, ang infimum of the sequence is 1/3 or 1/3 is the greatest lower bound. Pero 0 is also a lower bound. Kaya lang, ang greatest lower bound is 1/3. Nakuha?
Yes, ma'am.
Okay. A sequence is actually bounded above if and only if it has an upper bound and a lower bound. So the definition says that ang sequence is bounded kani if and only if it has an upper bound and so dapat na both ha kay end man and a lower bound. So kung upper bound lang ang naa, dili bounded ang sequence. Kung lower bound lang ang naa, dili gihapon bounded ang sequence. It will only be bounded if it has an upper bound and a lower bound. Kinahanglan ang duha ha. So we have the following theorem. That is, a bounded monotonic sequence is convergent. Kinahanglan daw, if you have bounded, then monotonic siya, convergent siya ang result. So, unsay definition sa bounded? If it has an upper bound and a lower bound. Unsay definition sa monotonic? If it is either increasing or decreasing. So, ang buot pasabton, ang kanang sequence nga nay upper bound and lower bound and either increasing or decreasing, it is convergent. Yun ang ibig sabihin ng theorem na to. Na? So, ang axiom of completeness says that every non-empty set of real numbers that has a lower bound has a greatest lower bound. So, kung naa daw mga lower bounds, dapat naagid sila'y greatest lower bound. Yan ang ibig sabihin ng axiom of completeness. Also, lahat daw ng non-empty set of real numbers na merong upper bound, so basta na-establish na nasa upper bound, dapat naa siya'y least upper bound. Again, unsa ning least upper bound? Muna yung supremum. Ang greatest lower bound mo na inyuhang infimum. Okay? Nasabtan ang axiom of completeness. Ang dami yung concepts ngayon na kailangang i-memorize, i-understand, no? So, you have to be prepared for all of this kasi sa exam, itong mga theorems, although you will not be asked to state it, you will be using all of these theorems, okay, in proving or in solving your problems. So, theorem 3.9. If A sub n is bounded above and increasing, then your A sub n is convergent. So, ang sa ano uli ang supremum? It's your least upper bound. Tandaan nyo lang na U. Then na U po diha. So, para dili mo malibog pag memorize na ang supremum is actually your least upper bound. Then ang infimum ninyo is your greatest lower bound. Asa na makuha ang least upper bound? Naa sa mga upper bounds. Okay? Ang pinakagamay sa upper bound mo na ang least upper bound. Ang pinakadako sa mga lower bounds kay mo na ang greatest lower bound. Nasabtan, kinsay gusto mag-repeat sa akong storya about upper bounds. What is the greatest least upper bound? I'm sorry. What's the least upper bound?
Least upper bound is ang supremum, ma'am.
Yes, meaning to say it is the saan na siya nga value? Pinaka gamay sa mga upper bounds. Okay. Ang greatest lower bound kay pinakadako sa mga lower bounds. Nakuha?
Yes, ma'am.
Okay, good. Now, you have to consider the following again. This is your activity 3.11. So, activity 3.11, di ba? Kuha naman ta ganiya, discuss naman ta on how to determine whether a sequence is decreasing or increasing. Okay. Kung decreasing siya, dapat i-show ninyo na decreasing, na greater than ang value sa prior, no? Kung decreasing siya. Pag increasing siya, you have to show na ang next na number, no, a sub n plus 1 is actually bigger. Okay? Then, you're also asked to find the least upper bound or, again, para matandaan nyo, upper bound kana, muna siya supremum na u diya, supremum. And you're also asked to find the greatest lower bound, okay, which is the infimum that value. So, anong gagawin ninyo? Identify sa anong elements sa inyong sequence, and then tang-awon whether increasing or decreasing, and then prove if it is decreasing, prove it that it is decreasing, prove it that it is increasing, and then find ang inyong supremum and find also the infimum. Okay? Activity 3.11. I'll give you time to do that. So, mga Wednesday na siya i-submit. Wednesday. Before sa ato ang klase. Kay Monday, magklase man tag 4:30 to 6. So, Wednesday, 10 o'clock ba ta? 12. 10 ta, no?
Sa Wednesday, ma'am.
Wednesday. So, before 10 a.m. dapat ma-submit ninyo online. Tapos, dalon lang ninyo ang hard copy also. Okay? Dalawa ito, 3.11 and the other one is 3.12. Let us discuss muna ito ulit. So, one of the most important theorems involving sequences is your monotone convergence theorem. And what is that? Nandito ba? Hindi ko ba nasulat? Sandali ha. 3.10, 3.11. We go back to the following. A bounded above. Pag bounded above, sequence is bounded above. If there exists, let me use the pointer here. If there exists a real number m such that your m here is greater than or equal to a sub n. So, muna yung boundary, no? Marag, gikural niya ang a sub n. Dapat less than or equal siya sa kaning ang a sub n ninyo. Or your m is actually greater than or equal to a sub n. Bounded above, nandito sa taas. Whereas, bounded below if ang a sub n is greater than or equal to your m here. Okay? So, kaning m ninyo mas gamay siya or pwede po ma-equal kay pwede man siya ma-element sa sequence sa a sub n for all positive integers n. So, a sequence is bounded sequence. Again, kanus siya mabounded if it is bounded above and it is also bounded below. So, kung pananglitan, ang sequence kay bounded above lang, then unbounded sequence, ihapon siya. Intan, ang coral. Coral na ito gamit na. Let's just make use of this. Ang coral, ay nagwain siya sa taas, kay wala, sa ubos na unbounded gihapon. Naman gihapon nabilin dito nga walay coral, di ba? Whereas, for it to be bounded, it should be bounded above and also bounded below. Okay? Na ay upper bound o na ay lower bound. Anabot pa sa ito. Okay. For example, kanina sequence, 1 over n. Wala ako na ini-erase yung mga ano para hindi ako na inyo na lang i-verify. Okay? 1 over n. When n equal to 1, you will have 1. When n equal to 2, you will have 1 over 2. Correct?
Yes, ma'am.
When n equal to 3, you will have 1 over 3. When n equal to 4, you will have 1 over 4. So, 1 over n man ang atong sequence. Okay. So, 1, then ang 1 half kay 0.5. Then 1 third kay 0.3, 0.25, 1 over n. What is Yes, is this increasing or decreasing na sequence?
Decreasing, ma'am.
Decreasing. Yes. So, good man ka 1. Then, nahimong 0.5 na lang. 0.3, 0.25. If it is decreasing, di ba na may tayo theorem ganina, pag decreasing siya, kaning 1 diri, di ba 1? Mao ang pinaka dako. Correct? Okay, paubos man ang number. So, we call this 1 is an upper bound. Ang number na mas dako pa sa 1 is also an upper bound. Correct? Ang 2, also an upper bound. Ang 3, upper bound gihapon. Pero ang least, ang pinakagamay sa mga upper bound is 1. Kani siya. Ani ang least upper bound to 1. LUB equals 1. Nakuha? Did you get it? Nang LUB is equal to 1. Pinakagamay sa mga upper bounds.
Yes, ma'am.
Correct. Sige. How about here? Notice na kay decreasing siya. Decreasing. Pag malaki na masyado yung n, what will happen? 1 over a very, very large number. It will tend to what value?
Approach check 0, ma'am.
Yes. So, 0 is actually a lower bound. Kaning 0, lower bound siya. Napay mas gamay sa 0 after that? Lower bound. Wala, hindi naman na siya man-negative, kaya positive man di ba? So, what is the greatest lower bound?
0, ma'am.
0. Although, you can have, after that, negative 1, mga values nga, dili na element sa sequence, mga lower bounds na siya, pero dili siya element sa sequence. So, ang greatest lower bound should be an element of the sequence. Ang least upper bound should also be an element of your sequence. Dili man siguro necessary nga element siya sa sequence. Basta, mag-exist lang ang upper bound o mag-exist ang lower bound. Okay? So, depende na siya later kung element siya sa sequence or dili. In this case, man God, if you take a look, limit of 1 over n, it will just tend to 0. Not necessary an element of the sequence. So, pero lower bound ang 0. Ang 1, which is an upper bound, actually is an element of your sequence. Okay? How about 2 to the n? Ang 2 to the n, notice na when n is equal to 1, you will have 2. When n equal to 2, you will have 2 to the second power, which is 4. When n equal to 3, you will have 8. So, 2, 4, 8, di ba it is increasing? Ang 2 to the n ninyo na sequence? It's increasing, correct?
Yes, ma'am.
Okay. If it is increasing, notice na naakay lower bound, 2, kay mo may pinakagamay. Pero, notice na after 8, ang sunod ana, 2 to the is 2 to the third, 2 to the fourth, and 2 to the infinity. Unbounded siya above. Bounded siya below, pero unbounded siya above. So, we have not bounded above. Therefore, although bounded siya below, ang entire sequence is unbounded. So, for it to be bounded, dapat both bounded above and bounded below. Nasundan?
Yes, ma'am.
Okay. 13, malapit na ba? Let us take a look at this one. Suppose a sequence is A7 is unbounded. Na? Then it is not bounded above or not bounded below or both. Diba? Kung unbounded siya. In either case, there are terms A sub n that are arbitrarily large in magnitude as n gets larger. So as a result, ang sequence kay dili siya mag-converge. Nasabta ni na statement, kung unbounded daw siya, then dili siya bounded above, dili po siya bounded below. Okay? For it to be bounded, dapat bounded above and bounded below. Diba? Or both. Okay? So, kung n gets larger, kay dili man siyang bounded, madako pod. Mahimo pod siyang, the magnitude will also get large. So, dili siya mag-converge. Therefore, being bounded is now a necessary condition for a sequence to converge. Dili man siya mag-converge to a certain value kay ano man, yang dili man siya bounded. Okay? So, mo nang ang boundedness is a necessary condition for a sequence to converge. Yung converge, padulong ato nga value. Suppose, ayan. If a sequence A sub n converges, then it is bounded. So, kung mag-converge siya ato nga value, then you say that it is bounded. Kay dito man siya padulong lang ato, no-converge siya ato. Note that the sequence being bounded is not a sufficient condition for a sequence to converge. Pero kung bounded siya, dili siya enough to say that it is convergent. For example, kaning inyuhang sequence nga negative 1 to the n. Diba? Nasolve naman natin last time nga, negative 1 to the n, when n is equal to 1, we'll have negative 1. When n is equal to 2, ma-add to siya sa positive 1. When n is equal to negative 1, ma-add to siya sa positive 1. When n is equal to 2, ma-add to na po siya sa positive. Positive na po, 1. N equal to 3, mahim po siya negative 1. So mag-oscillate lang siya between positive and negative. It will not approach a finite number. Pero, nag-divergent siya kay although bounded siya, dili man siya mag-approach sa certain value. Palit-palit lang siya. Negative 1, positive 1, negative 1, positive 1. Mag-oscillate lang siya. Okay? Okay. So, sufficient but not necessary condition for a bounded sequence to converge. This one, consider a bounded sequence A sub n. So, nakay, for example, bounded sequence. Then, kaning nga sequence is increasing. So, yung sa increasing, ang kaning next number kay mas dako sa prior number, no? So, you have greater than or equal to. Or, you can say that this number, the prior number, is less than the next number. So, that is what is meant by increasing. Since the sequence is increasing, the terms are not oscillating. So, wala siya nagbalik-balik ka na. Kaya increasing man siya. So, pataas, padako lang yun. Therefore, there are two possibilities. The sequence could diverge to infinity. So, when you say diverge to infinity, mean to say, ma-increase lang siya padako. No? Padulong lang siya sa infinity to a very, very large number. Or it could converge. Or padulong siya sa isa ka number. Increasing siya pero padulong siya sa isa ka value. However, since the sequence is bounded, so kay bounded naman siya, it is bounded above and the sequence cannot diverge to infinity. Okay? Kung kaning sequence increasing, pero bounded siya, kaning siya consider a bounded sequence. Bounded siya. Although increasing siya, padulong siya sa certain value, pero tama lang siya diri na siya m diha. Bounded above. Tama na ka, stop ka diha. Okay, maski dako pa. So it will be convergent to a certain value. That's why you conclude that A sub n converges. Okay? You have to review these concepts later on pag dili paghihapon nakuha, ha? Okay, let's take a look at this. For example, i-consider ni 1/2 is 0.5, correct? Ang 2 over 3, paki-check, 0.6 ba siya? Calculator. Hello?
0.67 mo.
Okay, 0.67. Dapat 0.7, no? So, ato na yung kuhan. Mo naghihatid sa ako nga value ganina. Atong rectify 0.67. Okay? 0.67. Okay. 3 over 4, 0.75. Correct?
Yes, ma'am.
Ang 4 over 5. Correct pa rin point 8.
0.8 po, ma'am.
Okay, so correct siya. So if you take a look at the values, is it increasing or decreasing?
Increasing, ma'am.
Increasing. Okay. Since the sequence is increasing and bounded above, so bounded above ni siya, asa ka ni padudurong? It actually converges. Okay? So naman ni formula ganina, no? Next, i-consider na po ni 2030,401. Then, ang sunod ay negative 1 half, negative 1 third. In fact, ang negative 1 half is your 8th term. No? A sub 8. Okay? So, even though the sequence is not increasing for all values of n, we see that, okay, this is increasing pero ang negative 1 half is less than negative 1 third. Ang negative 1 third is less than negative 1 fourth and down the line. So, starting with the 8th term, starting ani sa a sub 8, the sequence is increasing. So, eventually, ibig sabihin, this sequence, after kanina man na mag-follow, okay? Eventually, it is increasing. Since the sequence is bounded above, okay, bounded above daw ni, then, we say that it converges. Okay, naman siya, tama lang siya diri ani M, na siya bounded above diha nga M. So, taman lang diha. So, it is convergent. It is also true that if a sequence is decreasing or eventually decreasing and bounded below, it is also convergent. So, it also converges to that value. Okay? So, basta na siya boundary. So, again, nasa gani ang increasing? Kani ang definition. If your kaning next na term, mas ako siya sa prior term. Ha? Decreasing siya if kaning next na term kay mas gamay, less than sa prior term. So, a monotone, oops, asa na yun? Wala na ako. Sorry. Ay, sorry. Ano yun kanina? Malapit na kasi matapos. 23.2. Ayan. A sequence is a monotone sequence for all n greater than n equal to n sub 0 if it is increasing for all n greater than equal to n sub 0. 5:34. Namang ko consultation at 6 p.m. sa advisee. This is advisee. Okay? So, or decreasing for all n greater than or equal. So, we have the necessary definition to state now your monotone convergence theorem. Ang monotone convergence theorem gives a sufficient condition for convergence of a sequence. Kanya. Ano sa mga monotone convergence sequence? Theorem, sorry. If A sub n is a bounded sequence and there exists a positive integer n sub 0, such that A sub n is monotone. I mean to say either increasing or decreasing, no? Then A sub n converges. Yan ang inyong monotone convergence theorem. Kung sa gani ang bounded, dapat na siya upper bound and lower bound. Tapos, unsay monotone, dapat, okay, monotone either increasing or decreasing. Then, you have A sub n converges. So, duha ka condition, then it will be convergent. Example, this one. 4 to the n over n factorial. For each of the following, use the monotone convergence theorem to show that the sequence converges and find its limit. Let's try to take a look at first example. Kani, 4 to the n, what is 0 factorial? Hello?
1, ma'am.
1. What is 1 factorial?
1,
1 pa
1, ma'am.
rin. Yes. So, 4 to the n over n factorial. Sugod ta sa 1, no? When n equal to 1, 4 to the 1 over 1 factorial will give you 4. 4 to the 2, second, n equal to 2. All over 2 factorial, that is 4 squared. 4 times 4, 16. 2 times 1, so by 2 is 8. And then 4 to the third over 3 factorial will give you 32 over 3 and down the line. Okay? So, you already have an idea na kani ang element sa inyong sequence. So, notice also, at first, the terms, nagtagan akong ano. At first, the terms increase. However, after the third term, first, second, third, after the third term, the terms decrease. Kani, 32. In fact, the terms decrease for all n greater than or equal to 3. So how do you show that? You can show this as follows. That is 4 to the n plus 1 over n plus 1 factorial, which is your a sub n plus 1, is equal to 4 over n plus 1 times. Kani inyohang 4 to the n plus 1 can be rewritten as 4 times 4 to the n. Correct? Diba? The same base, ang exponent ani kay 1. Exponent ani kay n. So, n plus 1. Ang kanyang n plus 1 factorial can be rewritten as n plus 1 times n factorial. Correct? Hello. Nakuha. Equal ni sila. From here to here, they are equal. Correct?
Yes, ma'am.
Okay. So, nga kani, kay mo man ang inyong ala. Madagan. Kato siya. Where is it na? Okay. This one, kay mo man ni, kaning sequence ninyo. Which is your a sub n. So this one is less than or equal to a sub n if n is greater than or equal to 3. Diba? So good ani after the third term. Yan siya. Therefore, the sequence is decreasing for all n greater than or equal to 3. So also, the sequence is bounded below by 0. Why? Because 4 to the n over n factorial is greater than or equal to 0 for all positive integer n. So making use of your monotone convergence theorem, which was stated earlier, the sequence converges. Okay? So ang letter B, appreciate to find the limit. Kabalo naman mo ani kay nani sa math, pero just in case, nalimtan detailed man gihapon ang pagpangitaan sa inyong limit sa math 51. So ang activity 3.12, so 3.11 and 3.12 will be due on Wednesday. So, although mag-meet ka sa Monday, sa Wednesday pa siya due ang duha. Pero pagka Thursday, so ang isa kay determine, ang 3.12 kay kani, determine if A sub n is monotonic, find a lower bound and an upper bound kung naa, if any. Answer, is it bounded? Is it convergent? So if it is convergent, you have to show that it is convergent and justify your answer. So that will be due on Wednesday before kay 10 man mo, no? So before 10 sa online and then 10 ang inyong hard copy. Ang due sa Thursday will be kaning activity 3.13. So, the next day na po ang 3.13 kani siya. Calculate limit of a sub n. Show that it is bounded by giving an upper bound. So, three questions. Yeah. The sine inverse of 1 minus 1 over n for all n element of n.
Ma'am, sa 3.12 ba, ma'am? Activity 3.12.
Yes, sa 3.12. Ang sama.
Kanang 2 times 5 times 8 kay gimultiply na siya sa 3n minus 1, ma'am.
Bale, ang inyong first term, ang a sub 1, ang a sub 1 kay 2, 3 times 2 minus 1. Diba? So, if mag-start kag 3 times 1 minus 1, that will be 2 over n plus 1 factorial. 1 plus 1 over 2 factorial, 4 to the n plus 1. So, manang buto sabton. Sa first term nimo, 2 over 1 plus 1 factorial, which is 2 factorial, 4n plus 1. Ang second term nimo, kay may mo siyang 2 times 5 over 2 na pod na plus 1 factorial. Ang third term nimo kay mahimo siyang 2 times 5 times 8 over kanina po mahimo siyang 3 plus at 1, 2, 3 na no? 3 plus 1 factorial 4 to the 3 plus 1. Nasundan. Up to ang n term nimo kay kani 2 times 5 times 8 up to whatever that n is minus 1 over that. Nakuha?
So ang numerator, ma'am, is kanang 3n, ang mga terms sa 3n minus 1 gimultiply.
Ang numerator?
Ma'am.
Dili. Kani ang formula. 2 times 5 times 8. Mato ang first time nimo kay pag when n is equal to 1, 2 lang ang sa taas. 2 lang ang sa taas when n equal to 1. Kay mo yung siyang 3 times 1 minus 1. What is 3 times 1 minus 1? Diba? 2 man. So pagka
Yes,
second
ma'am.
term nimo, mahimo na siyang 2 times 5. Dalawa na. 2 times 5 na. Kay ang next man nimo kay 3 times, 3 times 2 minus 1. Na siya multiplier. So 2 then times 5 na po. Nakuha?
Okay. Yes, ma'am.
Pag third term, may siyang 2 times 5 times 8. Pero kaning dire, mapuli na po ni siya. 3 plus 1 na po. Okay, 3 naman. Nakuha? Kana siya.
Yes, ma'am. Thank you, ma'am.
Okay. Napay lahing question. So, duha ang activity ninyo ha sa Wednesday and sa Thursday. Sa Thursday kani. 3.30. Okay. So, these are the references. Pwede ninyong tanawan ng kay Lighthold na karing lecture notes. Mao naman ni akong gibuhat. Module 4 Infinite Series. Yung basic maka-download man mo ani. Basics of differential equations. So, mag-end na ta diha. Okay. I'll just keep the notations para inighatag na ko sa inyo na atong mga notes dito. Okay. File with notes. Save as. 9. With notes save. Yes. So, okay. I will see you on Monday class. Hopefully, pwede na ako makagawas. Mag face-to-face. I'll see you on Monday. I'll try to, nakapost na, paki-check ko nakapost na tong, katong notes na 9A. So, ang 9B, i-post pa na ako ng 9B. Dahil yun, what else? Check attendance tayo uli. Ilan na kayo? 20, nawala ng uban. Stop presenting. And then, so stop recording na lang tayo. Okay, stop recording.